This is a gym. This is a zoo. This is a museum. And you can even automate their creation. Hi, I am Robin-Yann Storm, and this is Gym, Zoos, and Museums. Your documentation should be in-game. First, who is Robin-Yann Storm? Who am I? I have over 15 years of game development experience. I was a tool designer at IO Interactive, working on the Glacier editor used to build the Hitman games. I was a tool designer at Guerrilla Games, working on the Decima editor and engine used to build the Horizon games. I was a tool designer at Apple in California, working on Reality Composer and Reality Converter. I was also a tool designer on the recently released Hightail. I am a co-inventor on 5 patents, which you can Google if you'd like, and nowadays I am a freelance product and UX designer working as a consultant. Now, why do video games need in-game documentation? It is because at any company there are games of telephone and information gets lost. For example, let's say you are wondering how far can a player jump? Maybe you are making a level and need to know the right distance for the geometry so a player can make the jump. You hear that Alex knows, but Alex says that Sam knows. Sam says it's on Confluence, so you look there, but it turns out it's on Slack. But the Slack channel for that is locked, so you have to ask for an invite. So you find someone to invite you, and then you finally get invited, and then finally you found it. You found the document that says how far a player can jump. That's a game of telephone. You're moving from thing to person to person to thing, and it takes a while to get your questions answered, which creates so much room for error. And this happens for many questions, such as how far can a player jump? Because I have to make sure the geometry in the level aligns. How low can a player crouch? Because otherwise the player may get spotted by guards. What is that animation called? Because someone says the animation cannot be found and they are trying to get it scheduled to be rebuilt. Or what is the name of that NPC? Because its name has already changed 3 times during development due to story revisions, so what is it called now? And these are all very normal questions to ask, because everything changes all the time. Some call that chaos, or a fast-paced environment, or agile, but however you feel about it, change is a natural part of iteration. And games have constant iteration. That's a good thing. But constantly having to update documentation is tough. Back in the day, I used to be taught a big GDD, a game design document, was the thing to make, and to then always keep it up to date with any changes. Those days have passed. This is not what you should be doing anymore nowadays, and you can check this yourself by asking a simple question. Are you shipping your documentation, or are you shipping your game? Now, at the start of a project, you should document. Please write down what you think the game should be. But when you're moving to engine, eventually you start building and experimenting inside the engine. You start to fully focus on the game, which means over time, you start to forget to update your documentation, and the documentation slowly but surely never gets updated anymore. And at that point, because you are so busy in the game itself, the documentation goes out of date, slowly but surely. At that point, someone will say, oh no, the documentation is out of date. But don't worry, that's normal. Again, iteration and change is expected. But updating documentation should be easy, not hard. And to make it easy, you should document your game in-game, spatially and contextually close to your content. So instead of updating 2 things separately, you build and document one thing at the same time. This is a core tenet of workflow design, working in context. Updating in-game documentation still takes time, but now you're updating one thing instead of 2. There are a couple of ways to build in-game documentation. The ones that I recommend are Gym, Zoo, and Museum. You may know these under different names: Test Maps, Metrics World, Showcase, Playground, Test Level, White Room, Player Zoo, Gallery, Mechanics Garden, Workshop. But for ease of use, I would urge you to stick only to the main ones, which were established way back in the 90s. Gym, Zoo, and Museum. Let's take a look through them, one at a time. Chapter 1, Gym. This is for character controllers, for player movement, and for character animation. Here's an example of the game animation sample from Unreal 5. You can just download this for free and try it out. We can see the character can run around, and we have some metrics that show things like this is 1 meter. You can jump over things to see how that works. There is something that is 2.5 meters, and you can climb onto it. So a gym allows you to understand the character controller very easily and quickly. You can even teleport to another place and do some more testing. Now, usually gyms are not released to the public. They stay internal during development. So what I've done here is create a little gym that showcases the usual elements, such as jump distances. Green is a good distance, that's easy. Orange is hard, but possible. Red is too difficult. It is too far away to jump. Imagine you can just hit play and run through this. Make that jump, see how it functions and understand it. Or here, corner cover. Green is great, while those round ones are orange. You know how in Assassin's Creed you can run along fences? We can see how easy it is to try that out here. And of course, the same thing goes for edge climbing. It's another big one that happens in a lot of games. How far can an edge be? How far can the player vault? It's all there right in front of us. So when someone asks how far can a player jump, instead of giving them loads and loads of documentation, having to find that one table somewhere that has the metric and it's being out of date, you just ask them to check the gym instead. Some games also release gyms as a shooting range or something like that. Here is one from Overwatch 2. You can load it up with any character you want. Then you can start shooting things to see how they work. You can pick up an item and see how it functions. For example, I instantly have my ultimate ready here. I can also shoot whatever enemy I want by going into this computer and selecting my enemy. I do not have to know what console command to use for what enemy or what their internal code names are. I can simply visually select them. Then I can use an ability and boom, there it is. This is not just useful for game players who use such gyms to make videos documenting your game for you. This is also useful for game developers. Or, as Jan David Hassel once told me, you can't ship a game without hitting the gym. A gym is also helpful for smoke testing and other automated testing. For example, let a character run through it overnight. Did the character get stuck? Is there a problem somewhere? Now we can tell everyone, hey, this character got stuck, this build does not pass the smoke test, so please do not give it to other people. We have to fix this first. And we can know where the problem happens. And we can easily verify that thanks to a gym. How far can a player jump? Check the gym, and you have your answer. What is the maximum terrain angle? Check the gym. There's your answer. How much damage does that ability do? Check the gym, and you have your answer. So, a gym allows you to have a single source of truth. I want to be very clear here. I am not saying don't document. I am saying know what to document where. Because engineers love reading text documentation, especially for APIs. Artists and designers, on the other hand, will not read written documentation with extremely few exceptions, such as narrative designers. This is also why I think generally narrative tools have such bad UX, because the user base of narrative tools more readily reads docs and is more able to get around bad design. But that's a story for another time. So, what makes a good gym? It has test cases for all major character environment interactions, it has descriptions of metrics, it has color coding and text, and it has teleportation and ease of use. So, that was Chapter 1. The takeaway being, use gyms. Now, Chapter 2, Zoo. This is for 3D art assets, items, and NPCs, for VFX, audio, materials, for vignettes, and art directors. Let me show you why you need a zoo. A classic problem for asset browsers is that you have a bunch of thumbnails, and if we zoom in here and look at that siege tower and the rocks above it, we have no idea which asset is larger. The siege tower is a little bit larger in the thumb, but how much larger? We cannot tell. In fact, we have no idea what the scale of any of these assets are. Also, what do they look like in the lighting of the level we are building? What does it look like in the dark or at sunset? We do not know. Now, there's some cool things that, for example, Unreal does to combat this problem. You can click and rotate a thumbnail to see what an asset looks like, right there in the asset browser. That's cool. But still, that rock and that ballista, are they the same size? Are the stairs the same size? By rotating the asset, I can see what the bottom of a siege ram looks like. Bam, there it is. That's nice, but I still can't see exactly what its scale is. By the way, thank you to Kenney for these Creative Commons Zero assets. Let's give a quick shout out to Kenney. Thank you so much for all the work you do. It's absolutely fantastic. Next, I'm going to go over some other assets. In Unreal, for example, here's a zoo. In the zoo, I can see what the assets look like. I can see what their scale is. I can see what they look like in lighting. You instantly see this information, so you know right away if this will fit your current level, creation, scale, and style. I could even set up a daytime cycle here and check it out in various lighting environments, such as nighttime. I can even zoom in on this much further and see the detail of the assets, like, oh, there's parallax on a material, lovely. That is information I cannot see in the thumbnail of an asset browser. What is nice as well for art directors specifically is you can set up little vignettes next to the zoo to showcase how the assets are supposed to be used. So anyone can see is how you put those assets together and make sure you stay consistent to the intended art style. So instead of asking questions like, what's the name of that item? Or wondering if to type a /spawn CR1284 into a console to make it appear. Or asking, what's the name of that vendor NPC? Or what level are they in again? Do I have to spawn into City Sewers 27 at X125 Y279Z10? Which are important questions, but take ages of time to answer. Again, they're games of telephone with way too much time and effort spent to get answers. Another big problem is asset names. For example, what would you type into an asset browser to find this asset? Shout out some names. Like, what would you type to find this? Be Iron Gate? Steel Gate? Turns out it's called Metal Gate. Now, what is the difference between metal, steel, and iron? Does it really matter? Only ever searching assets by name is a bad idea, and assets quickly get lost and sometimes even get rebuilt just because they cannot be found by name. With a zoo, you do not have to deal with these problems, and saves a lot of time. Here's a zoo from Counter-Strike Global Offensive for the level DE Nuke, which Valve released. You can even see with little text like, oh, these are the roof trims. What are the names of those roof trims? I don't care. I don't need to know any of their names to search for them. I can just look at the assets and pick the right one. Or these wires and cables, same thing. There are high poly and low poly versions. I can see all of them in the blink of an eye. You can instantly understand what you need to grab. No single name you have to remember. No single asset getting lost. Of course, you can grab data such as which assets are low and high poly programmatically where possible, or material complexity, health, LODs, and then show that data in-engine next to the asset in the zoo. Again, zoos are usually not released to the public, but here's one from Overwatch 2. This is like a 3-second segment from like a YouTube video they once published. I was like, oh my god, there's a zoo in there, so I have to take a picture. Here's another zoo I saw in a talk by Larian for Baldur's Gate 3. You can see in one level how every single helmet fits to every body type, facial structure, etc. Instead of having to spawn or load each one, you can see all of them right away. Great! Imagine how much longer this would take by having a single small previewer window somewhere and clicking from one body type to the next. What a waste of time! And here's one from a blog post and talk that Joel Burgess did about level design workflows for Skyrim at GDC 2013. But zoos are not just useful for 3D models. They can have so much more. You can also do this for VFX. For example, here's a zoo from Skin Deep by Blendo Games. We can instantly see all the VFX playing, instead of one by one in some previewer. So you can see what we'd like to use, fly closer to it, see its name, and then grab it. Like, oh, the electric defib VFX asset. I love using that. Looks and sounds fantastic. This process of laying out an asset goes back long ago to physical objects and tools. Physically, this is called knolling, which seems to have been coined by Andrew Kromelo in the 1980s. For example, here's a Lego creation knolled by Ren Breyer. And the result of that creation. Then more knolling, and more building, and more knolling, and more building, etc. You keep this process going until you have some nice Lego flowers. In fact, there's even a popular video game character who has been shown to do this. Hitman, Agent 47 in the Legacy trailer by IO Interactive. Look at all this neatly laid out gear. But you may be wondering, why is it called a zoo and not farm or some other word? To be honest, I don't think I was alive yet when the decision was made. It was long ago. But in the Half-Life 2 20th anniversary documentary, Jeff Lane mentions it.
Nova Prospect was different than a lot of the maps that I worked on, at least, is that in that we had some early art prototypes that were done. We have this whole concept of like zoo maps, we call them, which are basically like little art test scenes, how they would fit together, and some basic lighting.
So zoos started out as vignettes and eventually transitioned into layouts of assets in the days of Counter-Strike Global Offensive. I emailed both Jeff Lane and Eric Kirschmer to ask about the origin of zoo, but sadly received no response. If you know the origin of zoo or have examples from the 90s or earlier, please comment below. Any kind of asset zoo is fine, by the way, because you can build a zoo for any asset, including animations. Here is one for an Unreal character. We can see all animations right away, which also means we can easily debug them all right away. There's no need to know what the animation is called until we click on it and then see its name. You can also set up a zoo for hero assets only, or all the story NPCs in your game, or all enemies, or organize them for specific levels. The moment you are able to generate them, all of this starts to become very easy. Because yes, you can generate zoos. They do not require manual work to set up. For example, here's Asset Placer for Godot, made by CookieBadger. Again, we have that classical problem of a whole bunch of assets in an asset browser with only thumbnails visible. We have no idea what the scale of any of these assets is or what they look like in lighting. So we right-click here, and we click Generate Asset Zoo. And instantly, we can see what all the assets look like. We can see their scale in relation to each other, with no need to know any of their names and no assets getting lost. You can do this for any group of assets. Just boom, there's a zoo. This is not just tool design, this is workflow design. This is what I do for a living and I love it, creating better workflows for everyone in the project. Because you can combine multiple tools to create even more powerful workflows. For example, debugging workflows. Here's an asset zoo in Unreal. Can you point at which asset has an issue? That's easy, right? It's that one right there. We can zoom in on it. There's something wrong with its shader. Cool, we can fix it. Here's another one. Which asset is not loading correctly? Instantaneously, we know we can zoom in on it and find it and resolve it. Again, this is also good for smoke testing and other automated testing. For example, for zoos, I recommend making a screenshot overnight and comparing those to see changes or errors. Here's a screenshot from the zoo yesterday. Here's a screenshot from the zoo today. Let's compare the percentage of changed pixels. Have a lot of pixels changed? Well, is that because we received a lot of new assets, or is something broken? If a lot of change is detected by the system, it can automatically send both screenshots to your art director on Slack or email. If anything is broken, they can then fix it or tell someone else about the problem so they can fix it. Here's one more example. Can you find out which asset has a problem here? Sorry, that was a trick question. You can't see it. But if I turn on the shader complexity tool, now which asset has a problem? Again, instantaneously we can see this particular asset over here has really high shader complexity. Now we can fix it. So a zoo makes it so much easier to work with 3D assets in general. So what makes a good zoo? Well, displaying assets on a per folder, per use, and per level basis, having various lighting settings for each level and time of day, using scale references with textures or characters, and vignettes so art directors can show everyone how to use the assets. So that was Chapter 2, and the takeaway is, use zoos. Now, Chapter 3, Museum. This is for technology and systems, for shaders and rendering, and for physics and prefabs. Here's a little museum example from Unreal Engine. Again, you can download this for free as part of Unreal. This is a museum for the cloth system. It's a little level in which you can see examples of how the cloth system works. You can start playing it and instantly see examples. And if something breaks, we can instantly see it too. You can also place markers inside museums for more info. So there's a little green question mark you saw there. We can click on that and then link to, for example, API documentation or maybe an audio commentary node. This museum means we are not starting off with 40 to 50 pages on some Confluence wiki. Instead, we get instant visibility in how the system works with the ability to also read up about it if we want to. Unreal also has a physics system called Chaos Destruction. Look at how big their museum is for that. It just keeps going and going and going and going. It is a lot of examples. And again, instead of 50 pages on Confluence, you can just load up this level and see how it works. Everyone can instantly understand how the system is supposed to work. Skin Deep also released a map museum to the public. This is for UGC, user-generated content. This allows modders to easily understand the systems of the game. This is helpful because especially players never read documentation, and besides, many of the concepts shown here are much clearer in 3D than in text. In this case, the museum is one level, and from there you can load into other levels. So you only have to remember one level to load up. Everything else is easily reachable from there. Like for example, what's the player width and player height? It's this many units, so don't go over those. Don't make it smaller than that. What's the crawling height for a player? It's right there. We can instantly understand what's the jump height and also what countertops height should there be. It's in the museum. What's the clamber height? What can't we clamber? What's the crawl height? Instantly, we can understand everything like how high should the entities be on the wall? What's the size of the window should be? What are the size of stairs need to be? And this is not just for what you need to do, it's also for what you not need to do. For example, here's a section on no overhangs. Like, hey, you shouldn't be building overhangs, and here's an explanation for why you shouldn't do this. It's confusing for the player, our systems don't work well for this, or whatever it may be, so don't do this. Again, you can explain all these things to your developers internally and also to external people. Things such as, no clamber above clamber, don't do it. Something is going to mess up with our system if you do. And there's also lighting systems, like how does the lighting system work? Watch out for this, please do that, please don't do that. Please make sure your work behaves in certain ways. You can even look at this and like turn things on and off and like check out the lighting system right there in the museum. And also scripting. Like for example, here's a little scripting thing and it literally shows you as it goes through the script and it does the thing that the script is doing right there. So a little cat, it's going to come up, it's going to wait a little bit, it's going to talk a little bit and do an animation. Then it's going to do another animation that we're actually going to have to wait for because it's important. Yeah, that's it. All right, and now we understand how the system works. With a live example, anyone can run through on their own. Not big documentation, just shows how it works. So, what makes a good museum? Well, it functionally displays how the systems work, has text explaining the systems, contains links to technical documentation where necessary, and that takes us to takeaway number 3, use museums. So with gyms, zoos, and museums, they're not just in-game, they are spatial. And that brings us to the surprise chapter 4. Spatial documentation, which is useful for everything. For example, let's say you're at the start of building a game. You have a level that's not done yet. It's hard to see what everything looks like. You need to put some spatial documentation in there. Those are the farmlands. Dungeon number 2 is over there. Dungeon number 1 is over there. So we got the human city in this spot. We got the dwarven city over there. We got the deep forest over there. I don't need to look in some documentation or find the meeting in which something was discussed. I could just look at the level itself and see, oh yeah, dungeon number 2 is over there. Now it might change names, it might change locations, but I can instantly see where everything is. Like in a human city, I can even go in deep and get like, oh, like there's a quest 3 start location over there. I can understand where I need to debug something. If something should or should not move, I can indicate that like, hey, please don't move this. You can also use this for bug reports, design changes, general to-do tasks, whatever you like to document. For example, here's C Notes for Unity, a plugin by Ciro Continisio. With it, you can place these markers inside your levels inside the editor. And those markers contain data. For example, there's some grasses covering the road here, and there's a position of that. The category is to do, it's in this particular scene. There's no screenshots attached and no comments, but we can do that if we wanted to. And we can instantly see like, yeah, there's a problem there. So we can resolve it right there in the editor. We can click complete and we can document all kinds of issues. For example, these banners. Some art director probably said, oh, these are too long. So I left a little note saying like, hey, these are too long. You can resolve this, change it. So now when someone's doing the work, they can see that in game, right? And they also know not to document it again because they know it is documented right there in the game. Or this rock over here. It's rotated a little weird. So someone wrote down, hey, this rock has the wrong rotation. There's even a little screenshot attached. So we can see what that person originally saw when they were playing the game. So we double click on that and boom, we can see the screenshot and yep, it's obviously wrong. Something's wrong there, so we can fix it. In this particular case, C Notes does not support logging while playing a build and does not link to Jira, but you can imagine how those things would speed up the workflow even more. Because the devs see what they need in the context they need it in. Games have used spatial commenting systems like this for many years. For example, The Legend of Zelda Breath of the Wild used such a system for the open world. Everyone can comment inside the world and find each other's notes so that the world itself becomes the documentation. It can be helpful to have a world map view as well, in which important data can be easily looked up. Martin Thorsen did a great talk about this at GDC 2015, showing the database viewer he built for The Witcher 3. This talk is linked in the description. His database viewer can show things like vertex density and a top-down view of the world. It can also show high foliage counts and any other thing the user wants to search for. So then you know where the problem is and can easily navigate to that problem to resolve it. So we can see that this spatial context exists both in 2D and 3D. Another great example is visual scripting with node editors such as blueprints. Maybe you have a character blueprint, and so the backward root spine neck section gets a backward arrow icon for easy identification, and a setup sign neck section gets a setup gear icon. So you can leave comments and use emojis as icons for information that is spatially close to their context. Keeping context spatial in editor is helpful for workflows. Godot does this in a great way. If I have an object here, a node, I can right-click on that and say Open Documentation in the dropdown. It opens the documentation inside the editor. Not a browser window, but inside the editor. I can even go to a particular property of that node, right-click it, and say Open Documentation, and it takes me to the exact spot of the documentation where it tells me about that particular property. And if I wanted to go to external documentation, it's not going to stop you. You can still click on a button and open up a browser. I think Godot did an awesome job implementing this kind of stuff. This looks really, really nice. So what makes good spatial documentation? Well, they're easy to create with mouse, keyboard, controller, and even microphone sometimes. Maybe you type it out or even speak into it automatically to create the text or have the voice file play like in a commentary node. They have screenshots and ticket system integration. They contain links to external data where necessary. So that takes us to takeaway number 4. Build spatial and contextual documentation. And you can even combine these techniques like peanut butter and chocolate. You can combine spatial notes and zoos. So here's again a little demo from C Notes by Ciro Continisio. There are a bunch of assets here in the zoo and there are spatial notes attached. So we can see like, oh yeah, this needs material changes or whatever it might be. We can see it's in the art review category and a screenshot's attached. We can see who made the comment and then when they made the comment. Again, just grab that information automatically if you have it. Or another great combination, gym and zoo, which is kind of done by Apex Legends a little bit. I think this is really cool. Like you have all your item assets laid out here. You can see all of them. You don't need to remember what the console command is to spawn any of these items. They're all laid out. All the weapons, all the ammo, you can grab them. They instantly respawn. This is so much easier to work with, right? Like when someone's wondering, what thing do I need to edit? What does that look like? Can I try this out? Load up this item zoo and it instantly works. Like there's some health, there's some ammo, everything works together. You can even like just grab this gun and instantly start shooting because there's an enemy right there. so I can instantly start testing things. For QA purposes and automated testing, this is lovely. Now, you may wonder, is there a combination gym, zoo, museum out there? Well, there's one that I think comes close. An Evening with Infinity Ward from Call of Duty Modern Warfare 2, released in 2009. We can see characters placed together with assets, and we can see them move. We see multiple vignettes with the style and vibe of the levels and locations. There are also items, in this case guns, displayed clearly, and we can inspect and pick up each one and shoot right away. There's also a section for vehicles where we can see them in miniature form and in larger form. We can see sections with NPCs having animation and VFX, even displayed underwater. And I really like this one of a character rappelling down in slow motion. But you might ask, where's the shooting range? Well, it's over here. Do not press F. Because when you do, all the NPCs come to life and start shooting you, and you can shoot them too. So the next time that your documentation slowly goes out of date, instead, build a gym, build a zoo, build a museum, and document spatially. Thank you very much for watching. You can subscribe to see more videos about workflow design in the future, ask questions in the comments, and follow me on LinkedIn, Blue Sky, and Mastodon at RY Storm.